This video is dealing with the concept of absolute value. This is something that you probably talked about in Algebra 1, but we're going to start with a little bit of review of the basics of absolute value. So you see the definition up here, that the absolute value is the distance from a number on the real number line to the origin 0. And we use these absolute value bars, these vertical bars here, okay? So that is the absolute value of 3, which is equal to 3. That means we're 3 units from the origin. And in the same way, the absolute value of negative 3 is also equal to 3, okay? Because we're also 3 units from the origin. It's a distance, so the absolute value is always positive. Down here, this is the formal definition of absolute value. Okay, so the absolute value of x is equal to x if x is greater than 0. The absolute value of x is equal to 0 if I put a 0 in here. And if I throw a negative in here, like the negative 3, then I get a negative x, which means the negative of a negative x, so that will turn it positive. Okay, so that's kind of what this definition here means. All right, so what we really want to talk about in this video is the idea of absolute value equations, all right? And we're looking at 3 examples right here, okay? And basically, these kinds of equations, in most cases, are going to have 2 solutions, okay? So, for example, this one, what values of x would work here? Well, x could be positive 3, obviously. But x could also be equal to negative 3, right? Either one of those plugged into those absolute value bars would give us that answer, okay? Over here, x could be positive or negative 12, right? Okay, and that would work. How about on this example over here, all right? Absolute value of x is equal to negative 9. What number could I plug in here for x that would give us a negative 9 when we do the absolute value? Well, I don't think there is a number that's going to work there. So this one, no solution. NS, no solution. Okay? So hopefully that makes sense. Let's do a couple of quick examples. Actually, I'm going to run through this one and kind of leave you guys to do the next one on your own. All right? So the absolute value of x plus 2 is equal to 5. This is how I would like you to see. This is how I would like you guys to set these up. I want you to rewrite this in 2 parts without absolute value bars, okay? So the first part's going to be simply x plus 2 is equal to 5. And the second part will be x plus 2 is equal to negative 5, okay? So we're going to get 2 answers here, and the 2 answers are going to come as I rewrite this equation here. Well, this is pretty easy to solve here. If I subtract 2 from both sides, I'm going to get x is equal to positive 3 for this one. If I subtract 2 from both sides on the second equation, I get x is equal to negative 7. Okay? Now, just to show you guys that both of those answers work, if I plug 3 into the original equation for x, I get the absolute value of 3 plus 2 is equal to 5, and I can see that's going to work because this is a 5 and absolute value of 5 is equal to 5. If I throw the negative 7 in there, let's see what happens there. Negative 7 plus 2, taking the absolute value of that, and I want 5 for my answer. Well, if I evaluate this, I get a negative 5, right? But when I take the absolute value of that, I get 5. So that works as well, okay? So that's basically the idea of solving absolute value equations. I'm going to start you guys off on this next one just so you see the 2-part setup and then let you finish it, all right? So the absolute value of 2x minus 8 is equal to 20. So I'm going to rewrite this as 2x minus 8 is equal to 20. And the second one, 2x minus 8 is equal to negative 20. Okay? So that's essentially what you always want to do, and then you go ahead and solve those two parts individually. Okay, so here are 5 examples of absolute value equations that I would like you to copy down and work on, okay? And make sure you bring these to class and we'll go over them, okay? The first 3 pretty straightforward. Look at number 4 though. I have an absolute value of x plus 9 and then minus 2 is equal to 10, okay? So I'm going to give you this hint on this one. Go ahead and add 2 to both sides and get absolute value of x plus 9 is equal to 12, right? And then set this up into 2 parts, okay? All right. Let me just show you an example of one more type of absolute value equation. The absolute value of 2x minus 12 is equal to 4x. I went ahead and solved this out. 2x minus 12 is equal to 4x. 2x minus 12 is equal to negative 4x. And worked it out, and I got x is equal to negative 6, and x is equal to 2. Now, let's check those answers and see what we get. So absolute value of 2 times negative 6 minus 12, oops, that's a 12, equal to 4 times negative 6, okay? All right, so I have absolute value. This is 2 times negative 6 is negative 12 minus 12 is equal to, this times this, 4 times negative 6 is negative 24, okay? I do the inside subtraction. I get the absolute value of negative 24 equals negative 24. And I think I see a little problem here. When I do the absolute value here, I get positive, and that is not equal to negative 24. So this answer here, x equals negative 6, does not work. We call that an extraneous solution, okay? That's a solution that may not be correct. So what's important to do, especially in this type of equation where you have an absolute value equal to something with an x in it, okay? When you get those 2 answers, you better check both of them because one of them might not work. If you went ahead and checked this one, you would find that it would work, okay? So that's an example of an extraneous solution. So now I want to change and talk now about absolute value inequalities. So I'm looking at the absolute value of x is less than 5. And the question here is what numbers could be used for x that would make this statement true? Well, obviously, if I plug in to here, numbers like 4, 3, 2, 1, 0, I mean, those are all working. I could put in some negative numbers, negative 1, negative 2, and so on, okay? But if I get too big of a negative number, like could x be equal to negative 10? That's a 10. Negative 10? Well, I don't think so, because when I take the absolute value of that, I'll get a positive 10, so that is not less than 5, all right? So basically, what we have here are all the values for x from negative 5 to positive 5, okay? From negative 5 to positive 5 will work in this absolute value inequality. And if I look at the graph of that, it would look like this, okay? All of these values in here, all right, for x would give us solutions that would work here, okay? Now, this is what we looked at earlier in a video called a compound inequality, right? So what you have to do is take this absolute value equation or inequality and write it this way, okay? So here's some examples. We're going to write this as a compound inequality, okay? So absolute value of x plus 3 is less than 6. That would change into negative 6 is less than x plus 3, and that is less than 6, okay? And then you would solve this by adding 3 to all 3 parts, and that would give you the solution for this, okay? So like I said, the key is to change this into this, okay? So stop the video for a second and take a look at this one. So hopefully you got this as a compound inequality for this absolute value, okay? And then you should know how to solve this and also how to graph it as well. Oops. Okay. Now, let's finish this video off by looking at absolute value of x greater than 3, okay? Think about what values would work for x. Obviously, any values that are bigger than 3 I could plug in here, but think about the negative numbers, okay? I think negative values that are less than -3 would also work. So this is kind of what we're looking at for this one, okay? All the values that are less than -3 could be plugged in here and would work. -4, -5, -6. Plug them in here and notice that you'll get something bigger than 3. Over on this side, positive numbers bigger than 3 would also work in that absolute value. Okay? So again, the key is to solving these is to write them as 2 separate inequalities. Okay? So here we're looking at the absolute value of x plus 2 greater than or equal to 7. So I break this into 2 parts, one like this and one part like this. Notice on this part over here, all I did was remove the absolute value bars and wrote it exactly as it's written here. But on this one, I removed the absolute value bars, I made the 7 into a -7, and I turned this absolute value symbol around. Instead of greater than or equal to, it becomes less than or equal to, okay? So it's super important that you guys are able to do that. Notice, same thing with this one. Absolute value 2x minus 5 greater than 9. This one looks exactly the same without the bars. This one, I make the 9 a -9 and flip this guy around. Okay? There's one for you guys to take a look at. All right? Pause the video, see what you get. You should get those 2 absolute value inequalities. Okay? Those 2, well actually they're not absolute value anymore. We take the bars off, but that's what you end up with. Okay? So hopefully that makes sense. And you should know how to solve these after you get them to that point. Okay? All right. So here we go. Here are 4 problems for you guys to do. These 2 first ones, we have absolute values that are greater than or equal to. Okay? So remember how to set those up. This is a less than, okay? This one is a greater than. So the way that those are set up makes a huge difference. All right, so rewrite those, solve them out, bring them to class, and we'll talk about them when I see you next time.